Let's start with the next type of a conic section. That is, we are going to discuss about hyperbola. Now, how do we define a hyperbola? Very easy to define a hyperbola. Here, suppose let's say you have the x and y axis. Okay, so assume that you have the x axis, y axis. Now, in this x and y axis, let's assume that there are two fixed points on the x axis, or you can take y also, anything. Let's assume that this is 1 and this is one more. Clear? Say this is F1, say this is F2. So there are two fixed points, F1 and F2. Now there is another point, say some point P. Alright, some point P. Now this point is moving in such a way that the difference between the distances of this moving point with the fixed point. Again, I'll tell you the difference. So that means we have minus difference between the distance of this moving point to the fixed point. That means Pf2 minus Pf1. See, this is the difference between the distance of the moving point with the fixed point. Now, this value is always a constant. This value is always a constant. Now, this is what we call as a hyperbola. In the sense here, see the point P, it's going to move something like this. And it's going to move something like this. Now, the question will be, why do we have two graphs? One on the left, one on the right. Why are we having two of them? There could be just one, right? Not necessarily. Because see, this distance PF1 and this is PF2, right? What if the point is on the right side? That means what if you have a point somewhere over here? Say some point Q. So we can take something like this also. QF1 minus QF2. You can take it that way also. That's why the graph is on both left and right side. Now what are the parameters do we have in this hyperbola? See, hyperbola has same just like ellipse, parabola, all those things. Now the center is the origin. See, okay, it has two vertices. You can call this as V1 and V2. Okay, and F1, F2 are the foci. Now, when you look at this one, x-axis, the focus, both the foci, they are on the x-axis, right? So, x-axis is what we call as transverse axis. In the sense, transverse axis is that axis which contains the foci of the parabola. Transverse axis is that axis which contains the foci of the hyperbola. Now there is one more, the y-axis. See, this one is what we call as conjugate axis. Conjugate axis is that axis which is perpendicular to the transverse axis. Fair enough? This is what we call as conjugate axis. Now we have transverse axis, then you have the conjugate axis. So there are two axes for a hyperbola. Now after this, you have the center, you have the vertices, you have the foci, transverse and conjugate axis. Now these parameters, they define a hyperbola. Now in this case, the distance from C to V2 or from C to V1, this distance is what we call as A. Obviously this is A. Then the vertical distance would be B. Now from the center to F2 or from center to F1, this is C. That means F2 becomes C, 0 and F1 becomes minus C, 0. And V1 would be, V1 is going to become minus A, 0 and V2 would be A, 0. So this is how we define what is a hyperbola. Clear? And these are the parameters what we have in hyperbola. Now, just to quickly recap what is a hyperbola. Hyperbola is that conic section where the locus of a point is such that the difference between the point and the fixed point is always a constant. So this is how we define a hyperbola, and these are the parameters. So A, B, C, and of course you have the eccentricity, which we are going to discuss about this in the next video.